Okay, hold up. Yeah, we're recording. We're good to go. Okay, I'll edit out the first 15 seconds. Maybe I won't. You don't know. All right. So get your hair right. Get your smile right.
I think it's all. I think it's all set.
All right. Get yourself squared up in your camera. Um,
Yep.
okay. Welcome to episode 2 of Talking to Scientists. Last week, I had some of my PhD friends from Syracuse, and we are lucky enough to have another PhD candidate from Syracuse join us this week. And Alexander Johnson, why don't you introduce yourself?
Hi everyone. As Luke mentioned, I'm Alex Johnson, and I'm a PhD candidate at Syracuse University.
Well, let's just back up a second because I didn't even explain this in my last video. What is a PhD candidate for the people that have not been to grad school or are still on this track that don't know yet?
So a PhD candidate, it's in the title. So you're a candidate uh, to receive a PhD. But to kind of dig that deeper, PhD students, they have to go through a series of exams while they're doing their PhD. And at SU, there's 2 of them. So the first one is a qualifying exam. And so the qualifying exam, you're tested on some of the graduate coursework that you've already taken, and you're expected to link that coursework to some of the research and to some of the broader implications of like the work that you're doing.
So you're
And
saying
then
research, you're not saying like classes. So at this point of your academic career, you're not really like sitting down and taking notes and taking tests.
nope,
You're performing research and adding to the knowledge of the academic body.
that's correct. So basically at this point, I'm just uh, I'm just doing research and I'm trying to contribute to the research field that I'm working in. And so the candidacy exam was basically a test to see, can I do that? And I passed. And so now the goal is for me to continue doing that research and then finally then defend it at the end to receive the PhD.
Okay. So the PhD candidacy is really the end of a long road of academic study. So why don't you give us just a review of like where you're from and how you got to where you are?
Yeah. So I'm actually originally from Minnesota. And so back in high school, I actually wasn't really that interested in math and science, but I did really enjoy learning about the environment and trying to understand like environmental pollution. And so I went and got my undergraduate degree, and then I discovered that I really enjoyed research. And so then I decided to pursue a graduate study, and I eventually found my way to Syracuse and started at Syracuse University. And so actually, Luke and I, we met at TA orientation, so teaching assistant. And so we bonded over our like teaching responsibilities and research back in the day. And so we both started out as master's students, and I eventually completed my master's degree, and I did a thesis for that too. So I had to contribute to the research field at the end of my master's. And I took that work and I published it in an academic journal. And so in this journal, it's designed for scientists to communicate their research to other scientists working in the field. And
Well, I want to pause you real quick, Alex. So I just want to, this is a perfect example. We've been talking about in our classes about reliable resources and where scientific information comes from, because there are so many sources of misinformation and faux scientists on the internet these days that
mhm,
Alex is at the source, right? He's at ground zero of the academic knowledge that then gets sent to other academic personalities, scientists, researchers. That's what you do when you get a master's degree, is you actively contribute back to this body of scientific knowledge. Sorry, I just wanted to congratulate you and give you a little virtual high five on that.
Oh,
Go
thank you. Appreciate it.
ahead.
So the work that this journal was in was called Atmospheric Environment. And so this is a journal that's designed to communicate research on really anything about the atmosphere, like like the weather, or and particularly my field, like air quality and air pollution.
So this falls under environmental engineering.
Yeah, so this would fall under environmental engineering. So just pollution of air, water, soil, any of that would fall under environmental engineering. And
Okay.
so, um, in terms of like the work that I do, um, I I do both a combination of like field and lab work. So I basically, like, my research aims to. Um, did you have a question?
Yeah, I was going to let you finish, but I'll just ask the question now.
Okay, yeah, go
When
ahead.
you say you it's a combination of field and lab work, a lot of times in high school, the only experience that we have with hands-on stuff is in a lab. So what's the difference between lab work and field work?
So out in the field, it's kind of, you can think of it as like the prerequisite for lab work, because what I do is I collect samples out in the field, and then I take those samples back to the lab and I analyze the pollutants in those samples.
Field being the real world.
Yeah, you can think of it like outside, essentially.
Okay.
So what I have is I have these big collectors that collect pollution from the atmosphere. And by pollution, I mean particles. So you have particles all around you, and they're falling out of the atmosphere. And so we can collect them. And then what I do is I take these collectors and I like scrape them off, and I into like a sample bottle. So all these particles are in the sample bottle, and I take that back to the lab. I analyze the particles, and I can figure out some of the characteristics of like the pollution before the particles had fallen onto the collector.
What are some of those characteristics of pollution that you specifically look for?
So specifically, like how fast these pollutants are falling out of the atmosphere.
Okay,
Um,
I'm sure that's an important one.
yeah. So, and that can depend on a lot of different things, like where basically like where the pollutants are coming from, like how big those particles are, like how like kind of just the overall weather. So if the winds are really strong, that would like increase like the rate at which those pollutants are falling out of the atmosphere.
So it
There's
sounds
vi-
like, oh, sorry. It sounds like you got a lot of moving parts that you're taking into account when you do your research. It's not just I'm looking at pollutants, I'm looking at weather, I'm looking at where
yep,
pollutants are coming from, I'm looking at the types of pollutants that are coming down, I'm looking at the effects those pollutants will have, things like that.
yep. So it's definitely, there's a lot of different things to keep track of, and that's what makes it challenging, but also very interesting.
That's awesome. That's awesome. I want to get a little more like nitty gritty on actually what you do, right, with the field work. Because I remember back when I was doing my own field work, I helped you out a couple times. We had a little cross curricular activity.
Yeah.
Are they still like the big like discs that you leave out on a roof or in a field and collect atmospheric stuff from?
Yep. So I still got those big discs. So they're flat, circular, very thin discs that we use for collection. But now we've added these. You can kind of think of them as like bowl-shaped discs.
Okay.
Um, for basically, we have them side by side. And so what we're doing is now I want to link the air quality to like the water quality. So after, it's been some dry weather has passed, it'll rain eventually, and that rain will like hit the collector, and basically what you have then is that rain will wash off those particles or that pollution from the surface. And so now what I want to do is I want to measure like the wash off of those particles from a surface.
Interesting. So it sounds like, so let me paraphrase a little bit here. Um, if I'm a building, right, I get pollutants from the sky on me. What I would do
Yep.
personally when I get home from a long day is I go take a shower, and my shower washes the dirt, the grime, the pollutants off my body, but I don't have to worry about it. It just goes down the drain. What
Yep.
you're doing is you're thinking, okay, when a building takes a shower in New York City and all those pollutants are washed off of it by the rain, where do those pollutants go, and what effect do they have in the water when they leave?
Yep. So they'll
Right.
eventually go into your storm sewers, eventually to some kind of water body that's connected to those sewers. And those pollutants might not get treated during the treatment process. And so you have to think about, like maybe those pollutants might have an effect on, like the fish or any plant or animal life in those like natural bodies of water.
Yeah. I'm just going to draw a quick through line back to episode 1 of Talking to Scientists. We had Nick LaRusso on, who's also an environmental engineer, and he is doing a very similar research to what Alex is doing, but he's focusing on the water quality in rural wilderness areas and how that affects the vegetation, plant life, animal life, where Alex is really focused on how are we affected in urban areas, in our environments that we inhabit. That's really interesting. That's really interesting. Um, so we've covered a lot of ground. We've talked about a lot of stuff, but I really want to circle back to like you and your your connection to the work you do, and like how we talked about how and the steps you took to get from Minnesota all the way to Syracuse in your PhD program, but like what has kept you going? Why are you still in year 10, year 11 of college, university?
Yeah, just about. Yeah.
Yeah. So like why are you
Yeah.
still at it? Like why is this so interesting that you have kept at it? Why is it cool to you?
It's cool to me because I kind of like being behind the scenes, and kind of what I'm doing as a scientist is I'm, kind of behind the scenes trying to investigate like what the problems that we have are, like what are the actual environmental problems. And for the particular problems that I'm looking at, I think it's interesting because, these particles in the atmosphere, you really, a lot of them you can't really see, but yet they still have an impact on our overall quality of life. And so getting the chance to be able to like kind of understand these particles better and just use some like really cool equipment, expensive cool equipment, to understand them better. I think it's cool.
That is awesome. I want to go back to you said that have an impact on our quality of life. What kind of things are you saving us from? What pollutants are you trying to save us from? And what impact is that on our quality of life?
Yeah. So, I mean, maybe not necessarily like save us, but more just trying to maybe like reduce the damage on us and like on the environment.
Very humble
Um,
of you.
so a couple pollutants that I've been looking at are like nitrogen and sulfate. And so actually a lot of those pollutants don't come from Syracuse. They're not like coming from Syracuse. They're coming from air from the West, like the Midwest. And they're emitted by like power plants. And so they travel all the way up to upstate New York, and then they're actually gases, and then they condense into particles, and then they fall out of the atmosphere. But
Okay.
why they're important is because they react with like surfaces of buildings or like vegetation and essentially just damage them. But they can also enter your lungs and impact your respiratory system. And
Okay.
may, over time, exposure to these like pollutants may cause like lung damage or lung cancer or some other type of problem.
Wow, so there's actually a lot of impacts that this pollutants, so pollutants coming down to New York State that are not even from New York State have
Yep.
economic impact of damaging our infrastructure, our buildings, our roads, things like that. So we have to pay to repair things that have been damaged by some schmuck in the Midwest.
Yep.
And on top of that, we could be getting sick with like lung issues and respiratory issues. And I'm sure this is like, it's all on our mind right now. People who have pre-existing lung issues are probably more affected by this than your average Joe, right?
Yeah. And even just kind of linking some of this research to like current events from like the wildfires out west, like all that smoke is traveling to across basically the continent. And like the past month or so, if you've looked up in the sky, you can see that it's been sometimes maybe hazy or the sun is not as bright. Those are all particles that have been emitted from wildfires out west.
Wow.
And they're pretty high up, so they don't necessarily impact you in terms of they're not really getting into like your lungs or anything. But say if you lived out west, though, I mean, you're close enough to those wildfires where that those like wood ash particles will fall out of the atmosphere and impact you.
Maybe I'm getting a little out of pocket here because I'm
Yeah.
not that up to date with atmospheric conditions. But do you think that it's possible that some of those particles will come down in Syracuse and you might see them in your research over the next couple months?
Yeah. So, yeah, if there's, any kind of major temperature or pressure changes in the atmosphere, those that basically that you can think of the air as like mass. So these like air masses will eventually fall down essentially. And so actually we have been doing some measurements over the past month or so. So I would be interested to see if after collecting the samples, if we see any major changes in like the deposition behavior of these particles compared to what I was measuring before these wildfires started.
Let's back up just like 5 seconds to a vocab word that we need to define. Deposition characteristics.
So like deposition rate, so like how fast those particles are falling out of the atmosphere, or even just like their general like what they're made of. So like the composition might change.
So deposition meanings getting dropped out of the sky,
Yep, falling
landing on
out.
something. Composition, what they're made of.
Yep.
Okay, cool. Cool. Well, Alex, this is awesome, man. You've come a long way from the research that we were doing when we were in our master's programs together. This is awesome to hear you talk about.
Yeah, no, it's awesome to get to talk about it.
Yeah, yeah. Is there
Yeah.
anything else that you want to share with my class or anyone else who might see this video?
I would just like to share, if, for me, it's definitely been a long journey, and just, just keep at it, whatever you're doing, whatever you're working toward, just keep at it, and, keep your chin up, um, you know, in science, we experience, I'm talking about all these great things, but like, there's definitely a lot of things can go wrong, and like, failure can happen. And, my advice to you is, if you're working towards a goal and, you're struggling with it, it's okay, it's okay, just keep chugging along and keep your chin up, and, and always ask for help if you need it. Scientists, we're always there. We love talking about our work, and we love to help out other people who want to also do science. So just kind of to wrap it up, just keep at it. Do what you feel is best. Follow your gut, and keep at it.
That's awesome. I'm gonna clip just that last 90 seconds and make its own video right there, just with you, just normalizing failure, making it okay.
Yeah, it's okay. Yeah.
Science is about failing. Like you learn more from the experiments that go badly than you do from the experiments that go well.
That's
Uh,
right.
yeah, so that's awesome to hear. All right, man. Thank you so much. Thank you for being here, and
Yeah, thanks for having me.
I hope to have you back. Maybe maybe this later this year when I have a unit that aligns to what you're talking about. Maybe I can have you back and we can talk about something.
Yeah, that'd be awesome.
Cool. All right, man. Well, thank you very much for being here. Have a good one.
Yeah, thanks. You too.